Hello everyone and welcome back to PostNetwork Academy. I am Bindeshwar and I am really excited you are here today. In this session, we are diving deep into one of the most important foundations in linear algebra, vector subspaces. Whether you are aiming to master machine learning, design computer graphics, or build intelligent systems, understanding vector subspaces is essential. So let's get started and build a solid intuition that will power your mathematical and artificial intelligence journey. So let us understand what is a subspace. So let V be a vector space over a field K and let W is a subset of V. So W is a subspace of V if W is itself a vector space over field K with respect to vector addition and scalar multiplication from V. So that means it is itself a vector space over K and scalar vector addition and scalar multiplication. The fundamental property of vector space satisfies. Now suppose W is a subset of V, then W is a subspace of V if the zero vector that belongs to W, if there are two vectors in W, U and V, then their addition must be in W. That is a closure property of addition. And thereafter, if W belongs to U belongs to W and K belongs to field K, so KU must be in W. So these two property and three property. So that subspace would be of V. And if you combine, so this one you have to satisfy. This is, you can say that statement is equivalent to these two, combining these two. Now there's trivial subspaces, that means every vector space V has two subspaces. You can say that are trivial. 0 the zero subspace and V the whole space. So these are called the trivial subspaces of V. Now let us see an interesting example of subspace of RQ. So subspace is defined as the collection of vector where all elements of that vector are equal, and that is from RQ. So what kind of vectors we will have? 1 1 1, either minus 3 3 or 7 7 7. So we need to satisfy these three properties. So zero vector that belongs to U already closed under addition. So if there is U and V, so if you add them, so that would mean U because all are equal. Closed under scalar multiplication. So if you multiply, so that will also belong to U. So that means U is a subspace of RQ. Let us understand line subspace. So U is defined as all are equal points. A belongs to R, that is a field. So it passes through origin, that means zero vector. Closed under addition, that will also belong to U, and multiplication, that is also from U. That you can say that U is subspace of RQ. So this line subspace is subspace of RQ. Now plane subspace. So W is subset of RQ and let W be a plane in RQ passing through origin. So you can see that Zero vector is in W. Vector addition, that is close, and multiplication, that also belongs to W. That means W is a subspace of RQ. That means three properties: zero vector, closed under addition, scalar multiplication. So that subset would be vector subspace of RQ or R square, either may be. Subspaces of matrices. So let Mn the vector space of n cross n matrices, that means square matrices, and W subset of all upper triangular matrices, and W2 subset of all symmetric matrices. Obviously W1 is subset of V because it contains zero matrix, closed under matrix addition, scalar multiplication. So W1 is subset of V. Similarly, W2 is also subspace of V because it follows all the properties, or it has all the properties. Subspaces of polynomial space. So let V pt the vector space of polynomials, and Q is polynomials with only even powers of t. So you can see that there is a condition, but still it is subspace of V. So then Qt is subset of Pt. Polynomials we have taken. So constant we can have. So Qt is subspace of Vt. You can check all the three conditions. So here Qt is subspace of Pt. Now subspace of real valued functions. So let's W collection all continuous functions, and the second one W2 collection of all differentiable functions. Examples are here. So both W and W2 are closed under addition, scalar multiplication. So you can say that W1 and W2 are subspaces of V. So hope you understood the concepts that are very important in neural network and also large language models for fine tuning. You might have heard about LoRa algorithm, low rank adaptation. So linear algebra will help you in all your artificial intelligence journey. In robotics even it is used. So this is one of the important subjects, and you should understand each part of linear algebra. So hope you understood. For more resources you can visit website, YouTube channel, Facebook page, LinkedIn page, and there is also GitHub repository of code. So again, hope you understood. Thanks for watching the video.